Welcome back, Python Explorers. Today we are diving deep into the building blocks that makes our code come alive, operators and expressions. But before that, we get into the magic. Let's revisit the basics because mastering those foundations will make everything we're about to learn so much easier and, let's face it, a lot more fun. It all starts with a single line of code. Print hello world. You probably remember this as one of the first lines you typed in Python. It's like our hello to the programming world. And it's more than just tradition. That print function is Python's way of saying, let's show something to the world. We use this command again and again to display text, numbers, or even complex data structures on the screen. And see those quotation marks around hello world? That's a string, one of Python's core data types. String lets us work with text, which we'll see a lot in Python. Just for a recap, you cannot use capital letters in a function. So instead of print like with the lowercase p, you cannot just add a uppercase p. Adding uppercase p to print will make it a whole different function. In fact, it's not even a function in Python. So always use like a lowercase p, and this is a comment, by the way. It's a comment. If you see like a pound symbol or a hashtag symbol, what do you like to call it? This is a comment. And how do you make it? Either you started with a hashtag and then started with the symbol and then write something. Or if you already have something, just hit Control and forward slash on your keyboard to do the same thing. Python gives us several types of data: integers, floats, strings, and booleans. Each one is like a specialized container designed to hold a certain kind of information. Let's check out some examples. Here we have integer. So age is an integer because we have put 25, a whole number in it. We have float, which can be a height. 5'8" is a decimal number. Float literally means decimal number. String is just like a group of characters, a group of letters. So it's just normal text. We have Alice. And Boolean. So Boolean is student equals true. So Boolean is literally true or false questions. I have covered all of the topics in the previous videos. You can watch those videos for in-depth explanation. So it's just a quick recap of those. Variables are like label boxes that store these data types. So when we write age is equals to 25, this, you're telling Python to store the number 25 in a box labeled age. Then whenever we use age, Python knows exactly what we are talking about. It's a simple concept, but so powerful for organizing our code. And don't forget type conversions, also known as typecasting. This lets us change one type of data into another, like turning an integer into a string, or a float into an integer, etc. Type conversions are a big help when you need to combine different data types in expression or print them together. So we have our integer 25. If you use the single line of code, we can turn 25 to a string, and we have our float 5.8. Using this line of code can turn it into an integer. Now, with those fundamentals refreshed in our minds, let's unlock the power of operators and expressions. This is where Python really starts to feel like magic. Operators gives us control to calculate, compare, and create the logic behind our code. So let's create a new file. Let's kick things off with arithmetic operators. These are our go-to tools for math, from simple addition and subtraction to multiplication, division, and even powerful tools like exponentiation and modules. Let's see them in action. So we have a variable a and another variable b. So we have assigned a to 10 and b to 3. Let's get started with addition. So while adding these two numbers, we use this a plus b. So we have 10 plus 3, which gives us 13. And we have subtraction. Subtraction is just like addition. We just use the subtraction symbol. So a minus b, 10 minus 3 gives us 7. And then we have multiplication. Multiplication, we use this asterisk. So 10 times 3 is 30. As per division, we divide 10 by 3, which gives us this float number. And this is called modulus, also known as remainder. So a percentage b gives us 1. And then we have exponentiation, which is just exponents or just powers, basically. So we have a to the power, so we have two asterisks for powers or exponents. So a raised to the power b, which is 10 raised to the power 3, which gives us 1,000. Now there's this common misconception here. So if I were to write print a raised to the power for this symbol and again b, well, my friend, this is wrong because in Python, this symbol is actually not for exponentation or exponents or powers at all. This symbol is used for something else. So instead of that, if you want to power up, you have to use double asterisk. So now it's 10 raised to the power b. Or if you want to do any number squared, you can just times it by the same number for squaring the number. So if I do a times a, which is 10 times 10, is 100. So we have the 10 squared right now. And yeah, you cannot use the raise to symbol. You cannot use this symbol. This symbol is not used for exponentation. So these are the basic examples of the arithmetic operators. Arithmetic operators can handle everything from simple equations to complex equations. Experiment with them, try adding subtraction, and play around with numbers is an easy way to get comfortable with Python. Next up are comparison operators, which lets us compare values. Ever wonder if one number is greater than another, or if two values are equal? That's where these operators come in. We use the symbols like double equals to for equality, exclamation equals to for inequality. Then we have less than equal to, greater than, and greater than equal to. So here we have an example on the screen. We have x is equals to 5 and y equals to 10. For the equality check, we use this double equals to in order to check the equality. Since 5 is not equals to 10, it comes false. But if we were to take y is equals to 5, then it would have shown as true. Then we have greater than. So we use this symbol for greater than. We have y greater than 5, which is equals to true, because 10 is greater than 5, and we have y as 10 and x as 5, so therefore it's true. Then we have less than or equal. In this case, we have 5 is less than or equal to y, which is 10. So 5 is less than 10, but it shows equals to 10 too. So anyways, the answer is gonna be true since it agrees that 5 is smaller than 10, it's gonna be true anyways. These comparisons return true or false, giving our code the power to make decisions. They're a big part of creating if statements, which we'll dive into soon. Now let's step it up with logical operators. And, or, and not. These allow us to combine comparisons and create more advanced conditions. So we have this example on screen which age is 20 and a student is true. So we have this first as and operator. So we have print. Let's print it. Is this person an adult student? Which is true. If age is bigger than or equal to 10 and is student, then it's true. Or operators. Is this person a student or underage? Age is less than 18 or a student is true. So is this person a student or underage is true. Not operator. Is this person not a student? Not a student equals false. Is this person not a student, which is false? Logical operators give us the flexibility to create smart conditions, which means our programs can make decisions based on multiple factors. Lastly, let's talk about operator precedence. Just like in math, Python follows rules that determine which operations happen first. Multiplication and division, for example, come before addition and subtraction. So it's just like the order of operation that we learned in math. We have head mass, butt mass, bed mass, many other things. So here's an example. So in this line of codes, we have 5 plus 3 times 2. So if we look at our order of operations, we know that multiplication comes first and addition. So if we print it, we'll get 11. Because 3 times 2 is 6, plus 5 gives us 11. So multiplication happened first. If we were to say 5 plus 3, which is 8 times 2, which gives us 16, so it's not 11, so that's wrong. And with the order of operation, we have 11. But if you want more control, parentheses are your friends. They let you decide the order. So again, with the order of operations, we know that first you do parentheses, then comes multiplication, addition, and everything. So in this case, when you add a parenthesis, which is 5 plus 3 in parentheses times 2, addition happens first because you first solve what's inside the parenthesis, which is 5 plus 3, which is 8, and then you times it by 2, which is 16. So therefore, the result is true. And this gives you control over what you want to do. Like, it gives you control over which order you want to do first. And remember, associativity determines how to handle operators of the same precedence, usually going from left to right. While doing this operation, you'd like to go left to right. So we have our answer, which is 3. With operators and expression under your belt, you're on the path to become a Python master. These tools are the foundation of logic, calculations, and so more. Try experimenting. Combine operators and see what you can create. Don't forget to like, subscribe, and hit the bell icon so you don't miss any of our upcoming Python adventures. Next time, we'll take these operators and use them to make decisions in our code. See you then.